this tutorial video, I'll be adding preprocessor directives into a Unity project, showing you some things you can do with them and exposing some advanced tooling techniques near the end of the video. But first off, what are preprocessor directives? Well, in short, the definition from Microsoft is that they make your code easy to change and easy to compile in different execution environments. I've added a link in the description to resources for people that might want to dig in deeper to this topic than what I will cover here, which will be mostly Unity related. So let's dig straight in with a short example and see what we can do and what Unity provides us as far as these preprocessor directives are concerned. If you know about them already and how these preprocessor directives work, feel free to skip ahead using the chapters to the part where I jump into libraries and automating the setting up of these preprocessor directives in the project settings. So the first thing we're going to do is see this in action. So let's open up a script and we'll call this example. We'll open this up in Visual Studio. We'll get rid of this meat and we'll just keep with our awake statement. If I type into here, debug log hello, that statement will be written. Now with preprocessor directives and the defines, if I was to type into here hash if inside and then type in hash end if, I'll copy and paste my debug statement and I'll type into here inside. Now you'll notice that this is actually grayed out, and that's because this define hasn't actually been set up yet. Now if I come up the top and I type in hash define and then actually type it out inside, suddenly it comes alive. So this will now print out hello and then inside. Now we can extend this further. We can actually give it an else. So we type in here debug.log and then inside else. There we go. Now you'll notice that this is grayed out. If I remove this define, then suddenly it's alive. Now that's because it's saying if this define's been set up, then compile this into the code. Otherwise, use this inside else statement. Again, you can go even further with this with the term elif. And we could just say this is something like inside alternative. We'll just copy and paste this because we're lazy, and we'll type in alt into our statement. Now, if I put in the define at the top, inside alt, now we have that turning up. Because it's saying if this is set, which it's not, then do this. Else, if this is set, which it is, then do that. If none of them are defined, then it will do the last one, inside else. Now, obviously, we don't want to have this define set up in every script across our project if we want these things project-wide. So we can use the project settings in Unity to actually set these defines. So let's do that now. We'll get rid of it from this script and we'll use this inside directive to actually print out hello inside instead of the inside else that would currently be done. So let's save that script and jump back into Unity. So in Unity, we'll start by creating an object and calling it example. There we go. And we'll put our script onto here. So now if I press play while watching the console window, we get our hello inside else, what our statements were here. Now if we turn that off, let's define that inside directive. So if we come into edit, we go to project settings, let's dock that. We're in player, other settings, right down the bottom here, we'll type in capitals, because you've got to get it exactly right, inside, and then we'll apply that. Okay, let's come back into our game view, press play. And now, once it plays, we get hello inside. So going back into Visual Studio, we'll see this is now highlighted. And that's because we haven't got the define set up here, but we've got it set up in our project settings, and that will go through across all of our code space. So now that's all well and good, but Unity actually provides us some really handy preprocessor directives of its own. For instance, there's #if Unity editor. And what this actually does is it means that any statement, and I can put this in here inside editor, any statement that's currently being run while we're running our game in our editor will actually be compiled into the final source. But for our builds, Unity doesn't declare this Unity editor. So anything inside here when we actually do a build will be left off. It will be not included, which is super useful if we want to do particular editor style functionality within our scripts. You might have noticed before that if you happen to have a class that actually has Unity editor library included in it and editor functionality, maybe something you're doing in the on-draw gizmos or something like that, you've put in an editor function in there. But when you go to build, your build complains. It says this isn't defined anywhere. And that's because the Unity editor isn't sent along in the libraries with your final build. So what you can do is you can do #if Unity editor, and we can do end if there. And what this says is that while we are in the editor, we want this code available to be used. And as I say, things like on gizmos where you'll do lots of editor style functionality are actually really handy if you can use these directives. And for some things, you might find that actually you want to have editor specific. And there are things like OS X for Mac or Windows for Windows. Now, this becomes particularly useful if, say, you're doing pathing, because, of course, pathing to files on our systems are very different on the OS X than they are on Windows. Another very useful feature is to look at the build platform. So we have things like Unity Android, if I spell it right. So if we're doing an Android build, it will run on that. And I want to spell it correctly to do that. But here we're not doing an Android build. We're actually doing a standalone build. So we can actually type in standalone. And if I copy and paste the script in there, the debug, you'll see that it actually comes up because this is a standalone build that we've actually got this set up. And if I change the platform to Android and I have some Android functionality there, then that will happen. So you can imagine the benefits of this. If I'm running on an Android system with its lower CPU, lower GPU capabilities, then I can check for that. If I'm running very Android specific stuff, one of the cases I use it for a lot is if I've got analytics. I might have an analytics platform for one over another, or I might have a way of sharing that, networking, etc. So platform dependent statements like this are super handy. The other one that's very handy is if you're doing libraries and these libraries are shared across multiple projects, then you might have a problem that if one project's built for Unity 2020, one's built for Unity 2019, etc., you might find that the functionality that's in 2020 is newer, or some functionality in 2019 is obsolete. So you can actually specify Unity versions. So in here, I can come in and go Unity 2020, one or newer, or 2020 itself. So now, if there was functionality that's been introduced into 2020 or newer, then it will actually, this particular code that's listed inside here will actually be run. And if I have a project that's still using this same library, but it's on the 2019 build of Unity, this will actually be excluded. So you can keep updating your libraries, even if they're used in previous versions, using these statements. Now, on the subject of libraries, this is where it becomes quite useful to have these preprocessor directives. If I jump back into Unity, we can have a look. So I've got a timing library, and this timing library has the ability to slow down animations, pause the time, and apply timescale to it. And none of this is using the Unity editor functionality. It's all in my timing library. Now, I use this timing library across multiple projects, and I have other libraries that are included into those projects. For instance, I might have a movement library. And that movement library might have a rotate function for this windmill. Now, that would use, in this case, the timing library, because it doesn't want to use the standard Unity time. It wants to use my time control. So if a pause menu comes up, I could slow everything down or resume it as the pause menu goes away. But if I have another project that wants to use that movement library, then it becomes a problem that I have to also bring in the timing library with it. And this is where we can use our preprocessor directives. So let's say we have our timing library in my project settings. I might come into here and I might add a project setting called use timing library. And let's copy that because we're going to need that in a moment. So I apply this define symbol. And then if I was to create this new movement library, so folder, movement, there we go. And we'll create a rotate class in here. Now, if I open my rotate in Visual Studio, all we'll need is the update functionality here. We can say hash if use timing library, else use standard Unity. And let's see what that looks like. We've got our timing library here, and we could say float angle, and we're going to need a speed. So let's chuck in a speed up the top here. So serialized field, always add a tooltip. Speed of rotation, and we'll just speed, and we'll set this to 100. There we go. So my angle equals the speed. And because we're using my timing library, I can come in here, call the library, which is timing, .time.delta time. And then down here, where we're going to use it, we do our transform, we do a rotate, we set the vector here. So in this case, we're going to set it to the forward, and we're going to multiply it by the angle. Now, as I say, that's all well and good if I'm using the timing library. But if I'm not, we want to have an alternative. And the alternative is just to use Unity's standard time. And there we go. So this separate library, this movement library, now doesn't have to rely on having this timing library actually installed in the project. If it's not installed, it will use Unity's standard functionality. So if we're back in our scene, we come in and we select our windmill right at the end, and we put our rotate onto here. Now if I press play, we're using the library. You can see it slowing down there as all the characters slow down. But as I say, if I removed that timing library, it would just use Unity's standard time, because that's what we've got set up here. If use this timing library, else use that. Now, if we're using these libraries across multiple projects, the one issue we might come up with is having to set up these defines every time we do that. Because we might spell them wrong, we might forget to add one, and we'll wonder why when we're running our game that something's not working quite right. So it would be better, and as the tools programmer inside all of us, to actually create a script that sets these automatically as soon as we add our particular library. So let's do that. We'll remove the one that we currently have here in the define. We'll come into editor, and we're going to add a new script, and we're going to call that timing setup defines. We'll open that in Visual Studio. It's not a mono behavior, so we'll get rid of all this mono behavior stuff. And we're going to be using some editor functionality, so let's get in the library up the top there. Now, the first thing we're going to do is we're going to use this attribute called initialize on load. And what this does is it basically tells Unity that every time it loads or compiles these scripts in, that it's going to want to run this particular script. It's going to want to automatically run it. And that's helpful to us because we're going to want to run and set up our defines each time. So we'll come into here, we'll create this as a static class, and we're going to run the actual constructor each time. So we'll create the constructor here. Now I'll create the actual define up the top here. Define symbol, because we're going to use it across a couple of entries. And this is what we had earlier. So use timing library. And then we're also going to want to define the platform we're interested in. And in some cases, you could do this across multiple platforms, but I'm only interested in the standalone. Because as you saw earlier with the Unity defines, you can have defines for Unity Android, and you can have defines for Unity standalone. And if we look at the Android here, I've got my own symbols for Android, and I've got my own symbols for my standalone. You see that inside wasn't across both of them. So let's do that. We'll set up the build target group. Build target group, and we'll call this K build target group. And we're going to set that to be standalone because that's the one we're in at the moment. And as I say, you could make this an array and you could go across multiples and actually set them in multiple areas, but we're just going to do it for the standalone here. Now, the first thing we want to do is we actually want to get the current defines, because if we just write over them with all these new ones each time, then we're possibly going to lose defines that we already have set in our project. So we're going to want to add our define onto the end of it. So we'll use player settings. We'll do get scripting define symbol for group. And then we're going to use the target group we're actually interested in. There we go. So that will give us our current defines that we have set. Now, this actually comes out as one big string, and we want to do comparisons with each of the bits that are broken up. So we'll do string defines equals, we do the current defines, and we're just going to split that. And it actually uses semicolon to do the splits. And then we're going to want to go through those. So for int I is less than defines dot length increment. There we go. And we'll do a comparison. So string dot compare the define entry, and we're going to compare that against our symbol. And if it exists, well, we're not going to do it. We're going to return out. We're not going to need to carry on because we know it already exists. There's no point in swapping it out or anything. We don't want to do a recompile each time that we change the define symbols just because it already exists. So now we know it doesn't exist. What we can do is we can add it on to the end. So we can format it. Be added on to the end. So there we go. So we've added our separator and we've put it onto the end. And now we can actually separate. Now we can actually set those back with player settings dot set script defines for that group. Pass it the build target group we're interested in, and we give it the defines back. Awesome. So that's set. So now if we save, and now if we come back into Unity, it compiles the scripts. And it sets it for us. So again, if we were to remove this, press apply, come back into our scripts, put to Unity, does the reload, passes that, does the initialize on load, and then what we'll see as it compiles is it adds it automatically. I didn't do that, done it automatically. And that's how we can add are defined across all of our scripts. So you can imagine I can set up one of these scripts in each of my libraries that has that define statement in there, and then it will set that up for me and across my project. I plan on doing a longer tutorial on using libraries in your Unity projects and the automation around the process in the future. So make sure to subscribe to the channel if you haven't already so you don't miss that when it drops. But that's it for this tutorial. I hope you got something useful out of it. And if so, let me know by tapping the like button. There's lots more of these tutorials already uploaded, so make sure to check out the playlist for more little gems for you to pick through. And as always, thanks for watching.